The IEEE 1394 interface is a serial bus interface standard for high-speed communications and isochronous real-time data transfer. It was developed in the late 1980s and early 1990s by Apple, who called it FireWire. The 1394 interface is comparable to USB, though USB has more market share. Apple first included FireWire in some of its 1999 models, and most Apple computers since the year 2000 have included FireWire ports, though, as of 2014, it only remains as an interface on the Mac Mini model, being replaced by the Thunderbolt-interface on all other Mac models. The interface is also known by the brand i.LINK, and Lynx. IEEE 1394 replaced parallel SCSI in many applications, because of lower implementation costs and a simplified, more adaptable cabling system. The 1394 standard also defines a backplane interface, though this is not as widely used. IEEE 1394 is the High-Definition Audio-Video Network Alliance standard connection interface for AV component communication and control. FireWire is also available in wireless, fiber optic, and coaxial versions using the isochronous protocols. History and development. FireWire is Apple's name for the IEEE 1394 high-speed serial bus. It was initiated by Apple and developed by the IEEE P1394 working group, largely driven by contributions from Apple, although major contributions were also made by engineers from Texas Instruments, Sony, Digital Equipment Corporation, IBM, and INMOS SGS Thompson. IEEE 1394 is a serial bus architecture for high-speed data transfer. FireWire is a serial bus, meaning that information is transferred one bit at a time. Parallel buses utilize a number of different physical connections, and as such are usually more costly and typically heavier. IEEE 1394 fully supports both isochronous and asynchronous applications. Apple intended FireWire to be a serial replacement for the parallel SCSI bus while providing connectivity for digital audio and video equipment. Apple's development began in the late 1980s, later presented to the IEEE, and was completed in January 1995. In 2007, IEEE 1394 was a composite of 4 documents: the original IEEE STD 1394 to 1995, the IEEE STD 1394 A 2000 amendment, the IEEE STD 1394B 2002 amendment, and the IEEE STD 1394 C 2006 amendment. On June 12, 2008, all these amendments as well as errata and some technical updates were incorporated into a superseding standard, IEEE STD 1394 to 2008. Sony's implementation of the system, i.LINK, used a smaller connector with only 4 signal conductors, omitting the 2 conductors that provide power for devices in favor of a separate power connector. This style was later added into the 1394 amendment. This port is sometimes labeled S100 or S400 to indicate speed in bit S. The system is commonly used to connect data storage devices and DV cameras, but is also popular in industrial systems for machine vision and professional audio systems. It is preferred over the more common USB for its greater effective speed and power distribution capabilities. Perhaps more important, FireWire uses all SCSI capabilities and has high sustained data transfer rates, important for audio and video editors. Benchmarks show that the sustained data transfer rates are higher for FireWire than for USB 2.0, but lower than USB 3.0. Results are marked on Apple Mac OS X but more varied on Microsoft Windows. Intellectual property considerations. Implementation of IEEE 1394 is said to require use of 261 issued international patents held by 10 corporations. Use of these patents requires licensing. Use without license generally constitutes patent infringement. Companies holding IEEE 1394 IP formed a license administrator MPEG LA, LLC, to whom they licensed patents. MPEG LA sublicenses these patents to providers of equipment implementing IEEE 1394. Under the typical patent pool license, A royalty of 25 cents per unit is payable by the manufacturer upon the manufacture of each 1394 finished product. No royalties are payable by users. A person or company may review the actual 1394 patent portfolio license upon request to MPEG-LA. Implementers would thereby ordinarily reveal some interest to MPEG-LA early in the design process. MPEG-LA does not provide assurance of protection to licensees beyond its own minority subset of patents. At least one formally licensed patent is known to be removed from the pool, and other extra-pooled hardware patents exist that reference 1394 related hardware and software functions related to use in Ieee 1394. In total, over 1770 patents issued in the 20 years preceding 2011 contain Ieee 1394 in their titles alone, placing 1,500 unavailable from MPEG-LA. The 1394 High Performance Serial Bus Trade Association was formed to aid marketing of Ieee 1394. Its bylaws prohibit dealing with intellectual property issues. The 1394 Trade Association operates on an individual no-cost membership basis to further enhancements to 1394 standards. The Trade Association also is the library source for all 1394 documentation and standards available. Technical specifications: FireWire can connect up to 63 peripherals in a tree or daisy chain topology. It allows peer-to-peer device communication such as communication between a scanner and a printer to take place without using system memory or the CPU. FireWire also supports multiple hosts per bus. It is designed to support plug-and-play and hot swapping. The copper cable it uses in its most common implementation can be up to 4.5 meters long and is more flexible than most parallel SCSI cables. In its 6-conductor or 9-conductor variations, it can supply up to 45 watts of power per port at up to 30 volts, allowing moderate consumption devices to operate without a separate power supply. FireWire devices implement the ISO IEC 13213 configuration RAM model for device configuration and identification, to provide plug-and-play capability. All FireWire devices are identified by an IEEE UI64 unique identifier in addition to well-known codes indicating the type of device and the protocols it supports. FireWire devices are organized at the bus in a tree topology. Each device has a unique self-ID. One of the nodes is elected root node and always has the highest ID. The self-IDs are assigned during the self-ID process, which happens after each bus resets. The order in which the self-IDs are assigned is equivalent to traversing the tree depth first, post-order. FireWire is capable of safely operating critical systems due to the way multiple devices interact with the bus and how the bus allocates bandwidth to the devices. FireWire is capable of both asynchronous and isochronous transfer methods at once. Isochronous data transfers are transfers for devices that require continuous, guaranteed bandwidth. In an aircraft, for instance, isochronous devices include control of the rudder, mouse operations and data from pressure sensors outside the aircraft. All these elements require constant, uninterrupted bandwidth. To support both elements, FireWire dedicates a certain percentage to isochronous data and the rest to asynchronous data. In IEEE 1394 80% of the bus is reserved for isochronous cycles, leaving asynchronous data with a minimum of 20% of the bus. Encoding scheme: FireWire uses data strobe encoding. In DS encoding, two non-return to zero signals are used to transmit the data with high reliability. The NRZ signal sent is fed with a clock signal through an XOR gate, creating a strobe signal. This strobe is then put through another XOR gate along with a data signal to reconstruct the clock. This in turn acts as the bus's phase lock loop for synchronization purposes. Arbitration: the process of the bus deciding which node gets to transmit data at what time is known as arbitration. Each arbitration round lasts about 125 microseconds. During the round, the root node sends a cycle start packet. All nodes requiring data transfer respond, with the closest node winning. After the node is finished, the remaining nodes take turns in order. This repeats until all the devices have used their portion of the 125 microseconds, with isochronous transfers having priority. Up to 80% of the time can be given to isochronous nodes. Standards and versions. The previous standards and its 3 published amendments are now incorporated into a superseding standard, i.e. 1394-2008. The features individually added give a good history on the development path. FireWire 400. The original release of IEEE 1394-1995 specified what is now known as FireWire 400. It can transfer data between devices at 100, 200, or 400 Mbps full duplex data rates. These different transfer modes are commonly referred to as S100, S200, and S400. Cable length is limited to 4.5 meters, although up to 16 cables can be daisy-chained using active repeaters. External hubs, or internal hubs, are often present in FireWire equipment. The S400 standard limits any configuration's maximum cable length to 72 meters. The 6-conductor connector is commonly found on desktop computers, and can supply the connected device with power. The 6-conductor powered connector, now referred to as an alpha connector, adds power output to support external devices. Typically a device can pull about 7 to 8 watts from the port. However, the voltage varies significantly from different devices. Voltage is specified as unregulated and should nominally be about 25 volts. Apple's implementation on laptops is typically related to battery power and can be as low as 9V. Improvements. An amendment, IEEE 1394, was released in 2000, which clarified and improved the original specification. It added support for asynchronous streaming, quicker bus reconfiguration, packet concatenation, and a power-saving suspend mode. IEEE 1394 offers a couple of advantages over IEEE 1394. 1394A is capable of arbitration accelerations, allowing the bus to accelerate arbitration cycles to improve efficiency. It also allows for arbitrated short bus reset, in which a node can be added or dropped without causing a big drop in isochronous transmission. 1394 also standardized the 4-conductor alpha connector developed by Sony and trademarked as i.LINK, already widely in use on consumer devices such as camcorders, most PC laptops, a number of PC desktops, and other small FireWire devices. The 4-conductor connector is fully data compatible with 6-conductor alpha interfaces but lacks power connectors. FireWire 800. IEEE 1394b 2002 introduced FireWire 800. This specification and corresponding products allow a transfer rate of 786.432 Mbps full duplex via a new encoding scheme termed beta mode. It is backwards compatible with the slower rates and 6-conductor alpha connectors of FireWire 400. However, while the IEEE 1394A and IEEE 1394B standards are compatible, FireWire 800's connector, referred to as a beta connector, is different from FireWire 400's alpha connectors, making legacy cables incompatible. A bilingual cable allows the connection of older devices to the newer port. In 2003, Apple was the first to introduce commercial products with the new connector. The full IEEE 1394b specification supports data rates up to 3200 Mbps over beta mode or optical connections up to 100 meters in length. Standard Category 5E unshielded twisted pair supports 100 meters at S100. The original 1394 and 1394A standards used data strobe encoding with the cables, while 1394B added a data encoding scheme called 8B10B referred to as beta mode. Beta mode is based on 8B/10B. 8B/10B encoding involves expanding an 8-bit data word into 10 bits, with the extra bits after the 5th and 8th data bits. The partitioned data is sent through a running disparity calculator function. The running disparity calculator attempts to keep the number of ones transmitted equal to zeros, thereby assuring a DC balanced signal. Then, the different partitions are sent through a 5B/6B encoder for the 5-bit partition and a 3B/4B encoder for the 3-bit partition. This gives the packet the ability to have at least two ones, ensuring synchronization of the PLL at the receiving end to the correct bit boundaries for reliable transfer. An additional function of the coding scheme is to support the arbitration for bus access and general bus control. This is possible due to the surplus symbols afforded by the 8B/10B expansion. Symbols invalid for the current state of the receiving PHY indicate data errors. FireWire S800T, IEEE 1394C 2006 was published on June 8, 2007. It provided a major technical improvement, namely new port specification that provides 800mbits over the same 8P8C connectors with Category 5E cable, which is specified in IEEE 802.3 Clause 40, along with a corresponding automatic negotiation that allows the same port to connect to either IEEE STD 1394 or IEEE 802.3 devices. Though the potential for a combined Ethernet and FireWire 8P8C port is intriguing, as of November 2008, no products or chipsets include this capability. FireWire S1600 and S3200. In December 2007, the 1394 Trade Association announced that products would be available before the end of 2008 using the S1600 and S3200 modes that, for the most part, had already been defined in 1394B and were further clarified in IEEE STD 1394-2008. The 1.6 Igbit-S and 3.2 Igbit-S devices use the same 9-conductor beta connectors as the existing FireWire 800 and are fully compatible with existing S400 and S800 devices. It competes with USB 3.0. S1600 and S3200 development units have been made. However, because of FPGA technology, DAP technology targeted S1600 implementations first, with S3200 not becoming commercially available until 2012. Steve Jobs declared FireWire dead in 2008. As of 2012, there were few S1600 devices released, with a Sony camera being the only notable user. Future enhancements. A project named IEEE 1394D was formed by the IEEE on March 9, 2009 to add single-mode fiber as an additional transport medium to FireWire. Other future iterations of FireWire are expected to increase speed to 6.4 Gbps and additional connectors such as the small multimedia interface. Operating system support. Full support for IEEE 1394A and 1394B is available for Microsoft Windows, FreeBSD, Linux, Apple Mac OS 8.6 through Mac OS 9, Mac OS X, NetBSD, and Haiku. In Windows XP, a degradation in performance of 1394 devices may have occurred with installation of Service Pack 2. This was resolved in hotfix 885222 and in SP3. Some FireWire hardware manufacturers also provide custom device drivers that replace the Microsoft OHCI host adapter driver stack, enabling S800-capable devices to run at full 800mbits transfer rates on older versions of Windows and Windows Vista. At the time of his release, Microsoft Windows Vista supported only 1394A, with assurances that 1394B support would come in the next Service Pack. Service Pack 1 for Microsoft Windows Vista has since been released, however the addition of 1394B support is not mentioned anywhere in the release documentation. The 1394 bus driver was rewritten for Windows 7 to provide support for higher speeds and alternative media. In Linux, support was originally provided by LibRaw 1394, making direct communication between user space and IEEE 1394 buses. Subsequently, a new kernel driver stack, nicknamed Juju, has been implemented. Cable TV system support. Cable TV providers must, upon request of a customer, provide a high-definition capable cable box with a functional FireWire interface. This applies only to customers leasing high-definition capable cable boxes from their cable provider after April 1, 2004. The relevant regulation is 47 CFR 76.640 Section 4 subsections I and E. The interface can be used to display or record cable TV, including HD TV programming. Comparison with USB. While both technologies provide similar end results, there are fundamental differences between USB and FireWire. USB requires the presence of a bus master, typically a PC, which connects point-to-point with the USB slave. This allows for simpler peripherals, at the cost of lowered functionality of the bus. Intelligent hubs are required to connect multiple USB devices to a single USB bus master. By contrast, FireWire is essentially a peer-to-peer network, allowing multiple devices to be connected on one bus. The FireWire host interface supports DMA and memory map devices, allowing data transfers to happen without loading the host CPU with interrupts and buffer copy operations. Additionally, FireWire features 2 data buses for each segment of the bus network, whereas, until USB 3.0, USB featured only one. This means that FireWire can have communication in both directions at the same time, whereas USB communication prior to 3.0 can only occur in one direction at any one time. While USB 2.0 expanded into the fully backwards compatible USB 3.0 and 3.1, FireWire used a different connector between 400 and 800 implementations. Common applications: automobiles. IDB 1394 Customer Convenience Port is the automotive version of the 1394 standard. Networking over FireWire. FireWire can be used for ad hoc computer networks. Specifically, RFC 2734 specifies how to run IPv4 over the FireWire interface, and RFC 3146 specifies how to run IPv6. Mac OS X, Linux, and FreeBSD include support for networking over FireWire. Windows 95, Windows 98, Windows ME, Windows XP and Windows Server 2003 include native support for Ieee 1394 networking. Windows 2000 does not have native support but may work with third-party drivers. A network can be set up between 2 computers using a single standard FireWire cable, or by multiple computers through use of a hub. This is similar to Ethernet networks, with the major differences being transfer speed, conductor length, and the fact that standard FireWire cables can be used for point-to-point communication. On December 4, 2004, Microsoft announced that it would discontinue support for IP networking over the FireWire interface in all future versions of Microsoft Windows. Consequently, support for this feature is absent from Windows Vista and later Windows releases. Microsoft rewrote their 1394 driver in Windows 7, but networking support for FireWire is not present. iBrain offers free FireWire networking drivers for Windows called UbiCore, which support Windows Vista and later versions. Some models of the PlayStation 2 console had an i.LINK branded 1394 connector. This was used for networking until the release of an Ethernet adapter late in the console's lifespan, but very few software titles supported the feature, such as Gran Turismo 3. IIDC is the FireWire data format standard for live video, and is used by Apple's iSight AV camera. The system was designed for machine vision systems but is also used for other computer vision applications and for some webcams. Although they are easily confused since they both run over FireWire, IIDC is different from, and incompatible with, the ubiquitous AVC used to control camcorders and other consumer video devices. DV, digital video, is a standard protocol used by some digital camcorders. All divide cameras that recorded to tape media had a FireWire interface. All divide ports on camcorders only operate at the slower 100 Mbps speed of FireWire. This presents operational issues if the camcorder is daisy-chained from a faster S400 device or via a common hub, because any segment of a FireWire network cannot support multiple speed communication. Labeling of the port varies by manufacturer, with Sony using either its i.LINK trademark or the letters DV. Many digital video recorders have a DV input FireWire connector that can be used to record video directly from a DV camcorder. The protocol also accommodates remote control of connected devices, and can stream time code from a camera. USB is unsuitable for transfer of the video data from tape because tape by its very nature does not support variable data rates. USB relies heavily on processor support, and this was not guaranteed to service the USB port in time. The recent move away from tape towards solid-state memory or disk media has facilitated moving to USB transfer because file-based data can be moved in segments as required. Frame grabbers, i.e. 1394 interface is commonly found in frame grabbers, devices that capture and digitize an analog video signal. However, i.e. 1394 is facing competition from the Gigabit Ethernet interface. Ipod and iPhone synchronization and charging. Ipods released prior iPod with dock connector used i.e. 1394 ports for syncing music and charging, but in 2003, the FireWire port was no longer used in iPod and it was succeeded by Apple's dock connector. Since then, i.e. 1394 to 30-pin connector cables were made. Apple Incorporated dropped support for FireWire cables in iPod Nano, iPod Touch, and iPhone 3G in favor of USB cables. Security issues. Devices on a FireWire bus can communicate by direct memory access, where a device can use hardware to map internal memory to FireWire's physical memory space. The SBP2 used by FireWire disk drives uses this capability to minimize interrupts and buffer copies. In SBP2, the initiator sends a request by remotely writing a command into a specified area of the target's FireWire address space. This command usually includes buffer addresses in the initiator's FireWire physical address space, which the target is supposed to use for moving I/O data to and from the initiator. On many implementations, particularly those like PCs and Macs using the popular OHCI, the mapping between the FireWire physical memory space and device physical memory is done in hardware, without operating system intervention. While this enables high-speed and low-latency communication between data sources and sinks without unnecessary copying, this can also be a security or media rights restriction risk if untrustworthy devices are attached to the bus and initiate a DMA attack. One of the applications known to exploit this to gain unauthorized access to running Windows, Mac OS and Linux computers is the spyware in FireWire. For this reason, high-security installations typically either use newer machines that map a virtual memory space to the FireWire physical memory space, disable relevant drivers at operating system level, disable the OHCI hardware mapping between FireWire and device memory, physically disable the entire FireWire interface, or opt to not use FireWire or other hardware like PCMCIA, PC card, Express card or Thunderbolt, which expose DMA to external components. An unsecured FireWire interface can be used to debug a machine whose operating system has crashed, and in some systems for remote console operations. Windows natively supports this scenario of kernel debugging. On FreeBSD, the DCONS driver provides both, using GDB as debugger. Under Linux, Firescope and FireProxy exist. See also, Havey, Linux IEEE 1394 Target, Thunderbolt, List of device bit rates, Notes. References. This article is based on material taken from the Free Online Dictionary of Computing prior to November 1, 2008 and incorporated under the relicensing terms of the GFDL, version 1.3 or later. INSITS T10 Project 1467D Information Technologia Euro Serial Bus Protocol 3. ANSI INSITS. ANSI INSITS 375-2004, Anderson, Don. FireWire System Architecture. Mindshare, Incorporated. ISBN A0-201-48535-4, IEEE standard for a high-performance serial bus. IEEE STD 1394-2008. October 21, 2008 doi, 10.1109/IEAST. 2008.46592333. ISBN A978-0-7381-5771-9. External links, 1394 Trade Association, 1394 Standards Orientation, Introduction. IEEE 1394 Connectors Pinout.